Hi, I'm here at Intel headquarters in Santa Clara, and it's my pleasure to be speaking with Moh Haghighat, who is a senior principal engineer at Intel, one of the great brains behind Intel's optimizations of the browser and computing. And I'd love for him to describe in more detail some of the efforts that Intel is putting into for optimization.
For the application web runtime optimization, we have been involved in that for a very long time. In fact, I have been myself working very closely with Mozilla for the past more than 7 years. I myself was working on prototyping some JITting, just-in-time compilation, in Firefox 1.8. That was in like 2005, 2006. And then when the Tamarind project came, where Mozilla and Adobe decided to do a JIT for Firefox, then I was the technical lead from Intel in that project. And that Trace Monkey that was developed as that part of that collaboration was the very first JavaScript just-in-time compiler, shortly followed by V8 by Google, which is a remarkably good JavaScript engine. So we have been then working very, very actively on all these web runtimes since then. Intel, I mean, if you look at the data, the last data I saw was the #1 contributor to Chromium following Google. After Google, Intel was the #1. And if you combine Chromium and Blink, Intel is still #1 contributor following Google. On WebKit, Intel was the #1 contributor following Google and Apple, if you look at the data from the commit logs of the patches submitted to them. So we have been working on optimizing these runtimes for a very long time. Essentially, there are a lot of capabilities in Intel processors, and we just want to make sure that they are taken advantage in the most popular language of the world, which is JavaScript. And that area we have been working a lot on the performance part. On the parallelism part, we have been working for a very long time. Essentially, if you look back, these web runtimes, the main methodologies were designed in the 90s, where the mainstream was single core processor. But today, even if you look at the phones are multi-core with large vectors, wide vectors, and we just want to make sure that there is no gap in taking advantage of these capabilities. So we worked on introducing the first background JavaScript just-in-time compiler. That is essentially, instead of the VM waits for the JIT to compile and then continue, it could do it concurrently. It continue while the JIT continues. We did it in 2008, and that is the model which was adopted by Internet Explorer in 2010, and now it is in Chrome, it is in Firefox, it's in Internet Explorer, it's everywhere. Our colleagues at Intel Labs work on a concept called River Trail, which is essentially parallel JavaScript, and the work continues with Mozilla. And very recently, we have been working with Mozilla and Google on introducing SIMD, bringing SIMD to JavaScript, single instruction, multiple data. So a lot of work in HTML5 web runtimes.
I really recommend people watching this also reference the SIMD talk by Intel. That's an exciting technology. Also, I'm personally excited by some of the things that you describe, and I hope everyone out there realizes that when you hear about the incredible gains in performance that JavaScript has made, this is one of the main brains behind it. We all hear about Google and Mozilla, but we don't hear about the people behind the scenes as much, and so that makes me especially proud to be with you here today.
Thanks. It's a privilege to be talking to you. I mean, as I mentioned, I mean, the first big thing that happened in JavaScript performance was JavaScript just-in-time compilation. JITting essentially is like a 10x phenomena. If you look back like 8 years ago compared to now, JavaScript execution has become more than 100 times faster, and that is largely to just-in-time compilation, which basically exposes the meaning of what has to be executed and optimizes that for the processor on the fly. So that happened from like something like compared to native, if JavaScript was 300 times slower than optimized C++, with JITs, we came to the range of like 10x, 5x slower. And with some new development there, like type inference, which is now being taken advantage in the JITs, you're getting closer and closer. There is a very, very exciting project by Mozilla, ASM.js, that I'm sure you're aware of, that brings the gap from like 5x or more to about 1.5x if you look at the latest data from Mozilla. Then that is highly optimized C++. If you compare it with optimized JavaScript using these technologies, the difference is only 1.5x. That means JavaScript is really good enough, so for a lot of things. Now, as you know, Mozilla has been working with game companies like Epic to bring Unreal Engine with Unity on Unity Engine completely in JavaScript using ASM.js, mScripting technology. And below everything is just the mapping of JavaScript to processor instructions. And that is the area that we have been working hard, and we are very interested in that. The next big thing in native, if you really look at, is the SIMD instructions. A very large portion of silicon is dedicated to these vector instructions. Very, very large portion of the silicon. And up until now, these instructions were not at the reach of the JavaScript programmer in a programmatic fashion, that it was not available to JavaScript. With the work we are doing with Google and Mozilla in bringing SIMD to JavaScript, developers can write code that will map efficiently to these vector instructions. And you're talking about speedups of 4x, 8x, and so on, depending on the width of the vector. That is essential for domains like games, video processing, image processing, sound processing, what Intel calls perceptual computing, that you interact with computer in an intuitive way. The algorithms that make that possible have data parallelism inherent in them. Now, if you express that in JavaScript, before you couldn't map that, and it was slow. And even today, on the browser that you get, you don't have it. But we are solving that problem. And the talk at HTML5DevConf that my colleague Peter Jensen gave was an example of that. And Peter is actually our representative in TC39, ECMAScript committee. And our plan is to jointly with Google and Mozilla present that to TC39 so that for ECMAScript 7, essentially SIMD becomes part of JavaScript. Programmer can rely on it being very efficient. It would work on all platforms, whether they have hardware SIMD support or not, but it would be especially efficient and fast when it has a SIMD, like Intel architecture, like ARM with Neon instructions. That is the plan.
Wonderful. What's your vision of HTML5 and the future of the web?
We really think big of HTML5. We think it is the lingua franca of the new era of computing. If we look back at what happened in the PC era 20 years ago, applications were binaries distributed with CDs, etc. That was what it was. But then came along the web browser, and it changed the way programming. The computers are programmed forever. Now, basically, browser delivered the notion of writing once and running on any browser, on any operating system, on any hardware platform. We think HTML5 is the web reaction to the walled garden platforms on mobile. So the same cycle is happening again. Today, on mobile, apps come from this walled garden platform. They run only on the platform they were designed for. And HTML5 is the web reaction to these walled garden platforms. HTML5 is closing the gaps between native and the web platform on the mobile. There are so many new capabilities being introduced by HTML5, brought to the web platform, and we are getting closer and closer to the notion of writing once, running on any device, anywhere. And that is our vision of the future. Like web platform is the application platform of the future. It is just a matter of time getting there. And Intel is helping close the gaps to get there.
Well, one of the issues there is, of course, performance of the browsers. as well as internet connection. So can you speak a little bit to that and all the things that that Intel is doing there? I mean, I don't think people know how much Intel is involved with the browsers. So do you want to educate us a little bit on that?
So Intel basically has three broad areas of work as related to HTML5. One is the HTML5 runtimes. Intel is a major contributor to HTML5 runtimes. Second one is the HTML5 application development. Intel XDK makes HTML5 development much easier for developing, testing, profiling, building and targeting app stores and devices, deploying them. And involvement in W3C working group is another area. We really would love to be talking to application developers in the areas that can benefit from SIMD, essentially. And that is reasonably simple. Essentially, if they have been doing in the native world using SIMD capabilities, using intrinsics, that they would be basically able to do the same thing in HTML5 and getting very close performance from the work we are doing. So if people in the game area, in video processing, image processing are interested, we would love to hear from them. The spec, we started from by collaborating with John McCutcheon of Google. He is on the Dart team, and he had written the model for Dart. And then together with Mozilla and John, we revised it and enhanced it and extended that for JavaScript. We think it's a very good model. So it is still under discussion. So if developers would want to participate, we would welcome them to make sure it is complete for what they are doing.
So if somebody out there is thinking maybe they fall into that category, can you describe what kind of developers you're looking for specifically, what kind of knowledge they should have before contacting you, or how they would contact you?
Essentially, game developers that want to develop their games using JavaScript, using HTML5, and especially if...
It could be WebGL developers especially, or it could be people with the Canvas, or...
Right, anything that requires heavy-duty JavaScript processing. The JavaScript execution itself is a major part of the execution time, potentially can benefit from SIMD.
So matrix processing?
Matrix processing, exactly. We are actually going to, one of the things we will be working on is like kind of an optimized matrix processing using these things. And these are, again, as I said, available in the native world. And that is what is behind all these great, cool things that you see natively. We want to bring those capabilities to JavaScript. On the latest Intel processors, we have vector of bit 16. We have instruction that can transpose a 4x4 matrix in just one instruction, shuffle instruction. We want to eventually have that power in the hands of JavaScript programmer. And today, we have working demos of that in Chromium, in Firefox. We have submitted it to Chromium. The interpreter part of this has already landed in Firefox nightly, and we are working with Mozilla on completing the JIT part so that it'll become completely available in Firefox nightly. We also have a runtime called Crosswalk. Intel is using Blink, the latest Blink WebKit, and an open source project called Crosswalk, which brings the latest of these technologies together with enhancement that Intel has been doing. And the SIMD work that I mentioned is already integrated into Crosswalk, and it's in the hands of people. So people using Intel XDK, cross-platform development kit, can develop application using SIMD capabilities that targets Crosswalk. And currently on Intel tablets, on phones, you can get actually the SIMD speed up. But the rest will come along as the project continues. The support for ARM as well. We hope the ARM community will contribute to the project, the other part of that. So we are very excited about that because this is one of these kind of inflection points. Suddenly, if you look at the trend of JavaScript performance improvement, a lot of big things that could have happened that already have happened. We have got now to the point that improvements are incremental. But now with SIMD, suddenly we bring 4x speed up, like 8x speed up. This is a major things, major development, and would enable all these application domain that I mentioned.
Is the common user going to see all of a sudden a 4 times speed up, or it depends on the application? Obviously, if it's
right, it depends. Right, it is a capability that has to be explicitly used by the programmer. Okay. It is not something like in the JIT itself that automatically happens. Although automatic vectorization has been in the research area for a very long time. And also we do actually have that in Intel C++ compiler that the user writes, or sequential program, and the compiler detects that it can be actually parallelized and vectorized, etc. But what we are doing at this time is just making it possible to write such code. Now, such things like auto-vectorization, etc., can come later on. But as the first step, the programmer has to write program that way. And once they do program that way, if they develop libraries that are taking advantage of those things, then the user doesn't even need to know. It's like you use this matrix operation, magically you get the speed up. And you don't have to worry about that. Essentially, the heavy lifting is done by the JIT writers. In this case, it's like ourselves, essentially, that we have done the work. And then that, it'll be just faster. Another aspect of SIMD is power efficiency. That is, it is a lot more power efficient using this instruction. And mobile, exactly. So that is, in fact, on mobile, I think power story is a more compelling story for parallelism than just performance and responsiveness. It just serves both fronts.
And if someone does fall in that category where they are performance hotshot, want to play with SIMD, should they go to Intel developer site?
Correct. We do.
Your site on the web and just contact you.
Correct. It is already available in Crosswalk through Intel XDK. Okay. Just if you download Intel XDK, Intel XDK by itself is a world, like a lot of capabilities for debugging, on-device capability, debugging, performance, tuning, etc. Okay. Some of it are not possible elsewhere. But SIMD.js is also one of the capabilities that is now available through XDK, through Crosswalk runtime. But they would, I would welcome them. Contact us directly. I've written a blog about that. Contact us lately. We can possibly even make the prototype runtimes that we have available to them so that they experiment. But we are very actively working with Mozilla on making it part of the nightly. And that way you just get Firefox nightly, and then you can play with it. And I think for the really impatient developer, they're welcome to contact us. For those who could be a little bit patient, they can wait until it lands in Firefox. And again, we have submitted that also to V8. We are waiting to basically see that analyzed and processed and land there.
And then eventually we'll see some of these things in ECMAScript 7.
Right. And then, as I mentioned before, we plan to jointly with Mozilla and Google to present that this summer, this July. That is our expectation. Okay, well, TC39 committee. So.
I hope you can come and talk about ECMAScript 7 in the fall.
Would love to. Love to.
Thank you so much, Moh.
Thank you, Anne. Thank you very much.